Look up at the night sky. What do you see? For most of us, it's a moment of wonder, a reminder of how vast and mysterious the universe truly is. Above us stretches a vast dark canvas sprinkled with the glittering dust of countless stars, each one a tiny beacon in the cosmic ocean. Each of those stars could be a sun to its own family of planets, and beyond them, galaxies, hundreds of billions of them, each swirling with their own mysteries, their own stories waiting to be discovered. It's a spectacle that makes us feel small, yet deeply connected to something immense and ancient, a universe that has existed for billions of years before us and will continue long after. Now imagine for a moment, what if humanity could one day perform the ultimate act of creation? What if we could make a brand new universe from scratch with our own hands and minds? Not just a story, a simulation, or a thought experiment, but a real, physical universe, one that exists independently with its own reality, a place with its own space, time, matter, energy, and maybe even its own laws of physics, perhaps different from our own, perhaps stranger than we can imagine. This idea sounds like pure science fiction, the stuff of wild imagination. But physics has taught us that the line between impossible and not yet possible is always shifting, and what seems fantastical today could be tomorrow's reality. So, let's embark on a journey together, a thought experiment of truly cosmic scale. We'll explore 3 profound questions that push the boundaries of science and imagination. Is creating a universe theoretically possible? What would we need to achieve such a feat? What are the scientific hurdles and the philosophical implications? And could we actually do it today, with the technology and knowledge we currently possess? Or is this a dream for the far future? This isn't just about technology or science, it's about understanding our place in the cosmos, the limits of human creativity, and the deepest mysteries of existence itself. Strap in. Our spaceship of the imagination is about to launch. The adventure begins now. For most of human history, the origins of the universe were explained through rich and imaginative myths, stories of cosmic eggs, powerful gods, and world-shaping giants. These tales, passed down through generations, painted a universe full of mystery and magic, where creation was an act of divine will, or supernatural power. These stories gave people meaning, comfort, and a sense of place in the cosmos. But they weren't science. They didn't ask how things worked, or why the universe behaved as it did. Then, a new way of thinking emerged. Science. Instead of accepting stories, people began to question, to observe, and to experiment. People like Isaac Newton shifted the focus from who created the universe to how does the universe work. They sought natural explanations for natural phenomena. Newton's insight was revolutionary. The same force that causes an apple to fall also keeps the moon in orbit. Suddenly the universe was revealed as a place governed by elegant, discoverable physical laws. Creation was no longer just a story to tell around the fire. It became a process to study, a puzzle to solve, and a mystery to unravel. Einstein took this even further, showing that space and time themselves are not fixed, but a dynamic fabric shaped by energy and matter. The universe became even more astonishing. The Big Bang Theory replaced the idea of a single magical act with a vast, unfolding process, one that began nearly 14 billion years ago and continues to shape everything we see. Science didn't remove wonder from the universe, it transformed it. The more we learn, the more awe we feel at the scale and beauty of creation. The idea that all the complexity we see, from galaxies to life itself, arises from a handful of simple, universal laws, is breathtaking and humbling. If the universe was created by a mechanism, could we ever understand it fully? Could we one day even trigger such processes ourselves? Science took the story of creation out of the hands of gods and placed it into ours, if we are willing to learn the rules and keep searching for answers. Before we can even think about building a universe from scratch, we need to ask a fundamental question. What exactly is a universe? We need to define it clearly, because the answer shapes everything that follows. To physicists, the universe is the sum total of all space, time, matter, and energy that are connected, essentially, the entirety of the space-time fabric we inhabit. Imagine it as a vast, ever-expanding bubble, containing everything we can observe or interact with. We're inside this bubble. For on a tiny planet, and as far as we know, there's no way to step outside its boundaries or peek beyond its edge. But modern physics has opened the door to a mind-bending possibility. There could be other bubbles out there. Other universes, each with its own space-time, its own rules, and perhaps even its own versions of reality. This grand collection of universes is what scientists call the multiverse, a cosmic archipelago of separate realities, each isolated from the others. So, when we talk about creating a universe, we mean making a new independent bubble of space-time, a reality that's completely separate from our own, with its own beginning and its own fate. This new universe would start with its own version of the Big Bang, a unique explosion of space and time, expanding according to its own internal logic. The laws of physics inside might look familiar, or they could be utterly alien, with different forces, particles, or even dimensions. Once this universe is created, it would be forever cut off from us, pinching off from our space-time like a soap bubble drifting away, never to return. Creating a universe isn't like building a house with bricks and blueprints, it's more like planting a seed that grows into a tree in a completely different garden, one we can never visit. We set the initial conditions, the cosmic recipe, so to speak. But after that, the universe evolves on its own, beyond our control or observation. It would rapidly expand, creating its own space, its own time, and perhaps even its own forms of life or structure, all unfolding independently. Our act of creation would be like lighting a fuse, setting off a chain reaction that vanishes from our reality, leaving us to wonder what wonders or mysteries might unfold in that new universe, forever out of reach. How do you make a universe? Surprisingly, the total energy of the universe might be zero. Matter and energy are positive, but gravity is negative, balancing each other out. In a flat universe, positive and negative energies cancel, so you don't need infinite energy to start. It's like digging a hole. You create a pile of dirt and a hole. The net change is zero. This means a universe could arise from nothing without violating conservation of energy. But nothing isn't empty. It's a quantum foam, where particles pop in and out of existence. Usually, these quantum fluctuations are tiny and brief, but inflation theory suggests our universe began as a tiny fluctuation that got supercharged. A powerful energy field, the inflaton, caused a patch of space to expand exponentially, creating our cosmos. So, the recipe: start with a quantum vacuum, wait for a fluctuation, and add a massive dose of inflationary energy. If we tried to make a universe, what would we need? First, an incredible amount of energy packed into a tiny point, far beyond anything we can produce. This creates a false vacuum, an unstable state of space-time, like a ball perched atop a hill. To make a new universe, you'd create a tiny bubble of this false vacuum, which would then expand explosively. This is inflation. Next, quantum fields, the fundamental fields that give rise to particles and forces. You don't create these fields, you manipulate them with your burst of energy. This sets the stage for the particles and laws in your new universe. Finally, the laws of physics themselves, perhaps set randomly during inflation. We might not get to choose the laws. We just light the fuse and hope for the best. The universe could collapse instantly or flourish. We wouldn't know. Our role would be to start the process, not control the outcome. So, could we actually do this today? The answer is a resounding no. The energies required are far beyond anything humanity can produce. The Large Hadron Collider is powerful, but it's nowhere near the scale needed. Planck energy is a quadrillion times higher. Building a machine to reach those energies would require technology and resources we can't imagine. Even if we could generate that energy, focusing it without creating a black hole is another challenge. We'd need a unified theory of physics, something we don't have yet. For now, universe creation remains theoretical, not practical. Our current experiments are stepping stones, helping us understand the building blocks of reality, but we're still a long way from writing our own cosmic story. If we can't make universes, maybe nature already does. Some physicists propose that baby universes are born inside black holes. When a massive star collapses, it forms a singularity, possibly a bridge to a new universe. Our universe might have been born from a black hole in a parent universe, and our black holes could be spawning new universes. This cosmic family tree means universe creation could be common, not rare. Universes that make more black holes reproduce more, so their physical laws become more common. The conditions for making black holes also favor stars, planets, and life. We might be a byproduct of a grand cosmic reproductive cycle. What if you could create a universe inside a computer? That's the simulation hypothesis. With enough computing power, a civilization could simulate an entire universe, complete with conscious beings. If it's possible, how do we know we aren't living in a simulation? Philosopher Nick Bostrom argues that simulated universes would vastly outnumber the real one, making it likely we're simulated. Physicists look for clues, like whether space and time are pixelated, but so far, no evidence. Even if we are simulated, our experiences are real to us. The simulation hypothesis doesn't make life meaningless, it just reframes reality. We might be the product of creation, just not the kind we expected. Can we create a universe? For now, the answer is no. The hurdles are immense, but asking the question shows how far we've come. From myths to mathematics, we've uncovered our cosmic origins and learned the universe is dynamic and evolving. The quest to create a universe pushes our theories and dreams to their limits. Our path forward is exploration, building better telescopes, more powerful colliders, and searching for a unified theory. Each discovery brings us closer to understanding reality's operating system. These are the baby steps that might one day lead to a giant leap. Will we ever become creators? No one knows, but the pursuit of knowledge is noble, driven by the same curiosity that led us to the stars. The cosmos is our laboratory, its secrets waiting to be discovered. The journey to understand the universe is the journey to understand ourselves, and it's just beginning. If you found this information as fascinating and eye-opening as I do, then don't hesitate to smash that subscribe button for even more captivating science content.